In these problems, we are talking about something called permutation. And permutation is a way of calculating how many different ways you can combine groups of things. So for example, this second problem right here, it says 10 people are entered in a race. If there are no ties, in how many ways could the first two places be arranged? So, could it be this person and that person, this person and that other person? How many possible combinations of two people, when you're choosing them out of a group of 10, are there? We use this formula here where n stands for the total number that you're choosing from, and r stands for the number of things you're choosing out of that total. And often it'll be written in this p parentheses n comma r. Sometimes you'll see it like this, where there are little numbers standing for the n and the r. So if you were choosing two people out of a group of 10, you'd see it written like this. But oftentimes it's just in these parentheses. The formula for this is n factorial divided by n minus r factorial. So the numbers can get pretty big depending on how big the numbers are you start with, but it's all something that you should be able to calculate pretty easily. Well, let's look at a couple of these problems. This first one says, in how many different ways can two diamonds be drawn from a standard deck of cards? You have to be careful here because we're just talking about diamonds. So our total number, our n here, is going to be the number of diamonds in a deck. So n equals 13. R, we're choosing two diamonds out of that. So r equals 2. So if we use this formula, we're going to have 13 factorial over n minus r factorial. Well, n minus r, 13 minus 2, that would be 11 factorial. And I'm going to have on top 13 times 12, and then everything that comes after is going to cancel with the 11 factorial. So my answer really is just 13 times 12, which is 156. So there are 156 ways to choose two diamonds from a standard deck of cards. All right, let's do this one now where we have 10 people in the race, and there are, how many ways are there that the first two places can be arranged? So we've got an n of 10 and an r of 2. So we want this permutation. So we put the 10 factorial on the top and 10 minus 2 factorial on the bottom. And this is going to equal just 10 times 9, and then everything else is going to cancel with the 8 factorial. So this one is 90. Let's try another one here with playing cards. It says, in how many different ways can 3 black cards be drawn from a standard deck of cards? So our total here, our n, is going to be the number of black cards in a deck of cards, and that is 26. So n equals 26. Our r is 3 because we're choosing 3 black cards. So our formula here is going to be 26 factorial over 26 minus 3 factorial over 23 factorial. So this is really 26 times 25 times 24, and then everything that comes after will cancel out. So let's multiply 26 times 25 times 24, and I'm getting 15,600. That's a lot of different ways to choose 3 black cards from a deck. All right, and this one just says evaluate p of 9 comma 5. Well, this is our n, this is our r. So we would have 9 factorial over 9 minus 5, that's 4 factorial. And that's going to give us 9 times 8 times 7 times 6 times 5, and everything else would cancel with the 4 factorial. So punch that in my calculator, 9 times 8 times 7 times 6 times 5, and I am getting 15,120. So that is a little bit of work with permutation.